Hello, everybody. I hope you're having a marvelous Wednesday, and I hope you enjoy this pre-recorded video on lesson 25 on the topic of one-way variance analysis. And a one-way variance analysis is a statistical test that determines whether there is a significant difference in the means of three or more independent groups. So certain assumptions have to be made when deciding to use a one-way variance analysis test. The first is that the dependent variable is continuous. The second is that the independent variable is categorical with three or more levels. That the third one is groups are independent. Four, data is normally distributed, like in a bell curve, right? And five, variance of the groups are equal. If these assumptions are made, then a one-way variance analysis test is suitable. In lesson 25 of using SPSS, we are presented with a research study dealing with vitamin C. And that's a really good topic considering that either you or someone you know is sick. And it has to do with the amount of vitamin C intake and the number of days that a patient or individual showed cold-like symptoms. But to be more specific, the independent variable, like I mentioned, is the amount of vitamin C. So the independent variable is broken into three groups. One, the placebo, which is the control. The second is the low dose vitamin C. And the third group is the high dose vitamin C. And the dependent variable is the difference in the number of days with cold symptoms in the first year versus the number of days with cold symptoms in the second year. So now we're going to see what the data says. So I'm going to share my screen. I'm using a Mac. So here you could see that I have the data. I'm going to do the variable view so that you could see that I have the group. And here, as you could see, my groups are numbered. Number one is the placebo. Number two is the low vitamin C dose. And number three is a high vitamin C dose. So over here, the difference in the number of days with cold-like symptoms. So right now, I'm going to do the one-way analysis. So first, I'm going to go to Analyze. Then I'm going to do the general linear model. Then I'm going to do the univariate because the univariate is that there is one dependent variable. And then here, I'm going to go ahead and put the difference is my dependent variable, my group as my fixed factor because that's my independent variable. And then I'm going to select options. I'm going to click on descriptive statistics, estimates of effect size, the homogeneity test, and then I'm going to go ahead and put continue. And then I'm going to select the post hoc test, which is pairwise comparison between groups. And then I'm going to go ahead and select it. I'm going to select the Tucky test. And the Tucky test is a test that tells us, like, compares the three groups and tells us which group is really different from the others. I'm also going to use the REGWQ test, which is when there's an unequal sample size of the groups. Then I'm going to also select the Dunnett C test, which compares all the groups to a single control group. And our single control group is the placebo group. So then I'm going to go ahead and click continue. I'm going to click OK. And ba-da-bum-bum-bum, here we go. It's done for us. We put it in the oven and they calculated it for us. So here, as you can see, we have the between subjects factors, the descriptive statistics. Here we have the participants. We had 30 and the 10 in each group. Then we had the Levine's test of equity of error variance here, and you can see our significance. You can see the test of between subject effects, and over here, multiple comparisons and homogeneous subsets. So one of the things that I will mention here, the significance, and we will mention it in our APA output results, is that it was 0.16, which means that it is significant because anything that is below 0.05 is good enough to reject the null hypothesis, which, remember, the null hypothesis tells us that there is no relationship between the variables. When we reject it, we are saying that there is a relationship. So what we are saying here is that there is a relationship between the amount of vitamin C and the number of days with cold-like symptoms. And then here, as you can see, it is a partial eta squared. That is 26%, which is also a strong effect. So what we are saying is that it indicates that 26% of the variance in the dependent variable is attributed to the independent variable and excluding other factors. So in other words, 26%, if you were to do this again, 26% is more than likely what you would see in the population, right? And remember, we always use the sample size when we are doing statistical tests because it's almost impossible to do the whole population, time, money. So whenever we do statistics, we have to get a representative sample. The better the sample, the less we reduce the sampling error and so forth. But how do we display our data in a something pleasant to the eye, easy to read? We like to go to graphs, and then when we go to graphs, we're going to do the block plot. When we do the block plot, I'm going to go ahead and put simple, and then I'm going to put the group as my category and my difference in the variable, and then I'm going to do okay. And then right here, as you could see, it breaks it down for me in a visual aid. And I could see that right here, my placebo group, my low vitamin C dose, my high vitamin C dose, the difference in the number of days with colds between years. The one that has the greatest difference in the number of days and the intake of vitamin C is right here. And then here you can see our outliers. So again, using SPSS does all the math for us so that we don't have to. So I hope you enjoyed this lesson and thank you for listening. And now, if you have any questions, please ask ahead.